When I first released my video on building an AI health chatbot, I honestly thought it would just help a few curious learners explore machine learning and natural language processing. The chatbot I showcased was simple in its presentation. It lived entirely inside the VS Code terminal. You typed in your symptoms and it responded with intelligent prediction about possible health condition. Nothing fancy about the interface, just black text on a console screen, but it worked beautifully. I uploaded the video, closed my laptop, and went about my day. What I didn't expect was the wave of feedback that began to pour in almost immediately. Within hours, comments started popping up on YouTube. People were genuinely excited. They were impressed that such a practical AI application could be built with open source tools and a bit of Python magic. But alongside the appreciation came a recurring question, sometimes politely asked, sometimes almost demanding. This is awesome, but can you make it run on the web? It didn't stop there. Over the next few days, my inbox filled with messages from viewers who wanted more than just a terminal app. Some were developers imagining it as a public health tool for their community clinics. Others were students eager to host it online as a final year project. A few entrepreneurs even hinted at using it as a starting point for real world health services. The consensus was clear. The terminal version was powerful, but it needed a modern web interface to truly shine. The feedback stuck with me. I kept thinking, if so many people see potential in this, why not take the next step? I wanted to honor the original project while expanding its reach. But I also knew it wouldn't be as simple as copy pasting code. Moving from a terminal only experience to a browser based application meant rethinking the architecture, integrating front end technologies, and ensuring that every core function, symptom extraction, machine learning prediction, follow up questions remain intact. So I began experimenting. I mapped out how the chatbot's random forest model and NLP pipeline could run behind a lightweight web framework. I played with different UI ideas, a clean chat window, a responsive layout, smooth scrolling for long conversation. My goal was to keep the intelligence exactly the same while making the experience more accessible and inviting. Days of late night coding followed. I faced bugs, development headaches, and occasionally, why isn't this API responding? Moments. But with every small breakthrough, the chatbot answering accurately through a browser, the page updating in real time, I felt closer to what the community has envisioned. And that brings us to today's video. In this episode, I am thrilled to share the entire process of transforming the original terminal based AI health chatbot into a fully integrated web application. You will see how I built the front end, connected it to the existing machine learning model, and ensured that all the diagnostic intelligence from the first version remains completely intact. This isn't just an upgrade in looks. It is about making the chatbot easier to use, easier to share, and far more impactful. If you loved the original project, or if you're simply curious about taking a Python script to the web, stay with me because this journey is all about turning community feedback into reality. From Flask, import Flask, render template, request JSONify session. Flask creates the app, render template renders the HTML templates, request access the incoming HTTP data, JSONify sends the JSON responses, session stores the per user data across requests. From Flask session, import session enables the server side session storage data saved on the server. Import RE, random, pandas as PD, numpy as NP, CSV warnings. RE stands for regular expression, random for random choice of codes, pandas and numpy for data handling, CSV for reading CSV files, and warnings to suppress the warnings. From sklearn import preprocessing. From sklearn.assemble import random forest classifier. From sklearn.model selection import train test spread. From difflib import get close matches. The machine learning tools helps enable encoding, random forest model, and train trace split, get close matches for fuzzy text matching. Warnings.filter warnings ignore category precaution warnings, silences the specific precaution warnings. Flask app configuration. App equals to Flask name. App.secret key equals to super secret. App.configuration session type equal to file system. Session app creates the Flask app, creates a secret key for session encryption, stores session on file system. Load and prepare data. Training equal to pd.read.csv. Data training.csv. Testing equals to pd.read.csv. Data testing CSV. Reads training and testing datasets. Training.columns equals to training.column str replace rejects equal to true. Testing.columns equal to testing columns str replace rejects equal to true. Removes dot one and dot two etc. for all column names. Training equal to training.loc. Training columns duplicate. Testing equal to testing.loc. Testing.columns.duplicate. Drops the duplicate columns. Columns equal to training columns minus 1, x equal to training columns, y equal to training prognosis. Features the all columns except last. Labels equal to disease prognosis. LE equal to preprocessing dot label encoder, y equal to LE dot fit transform y. Convert disease names to numeric codes. Xtrain, xtest, y train, y test equal to train test plate x, y test size equal to 0.33, random state equal to 42, split data for training and testing, model equal to random forest classifier, n estimators equal to 300, random state equal to 42, model.fit xtrain, y train creates a 300 tree random forest and trains it. Dictionaries for extra information. Severity dictionary, description list, precaution dictionary equal to symptom dictionary equal to symptoms, IDX for IDX symptoms in numerator X. It creates empty dictionaries for severity, description, and precautions. Symptoms dictionary maps each symptom to its column index. Helper function to load metadata. Get description with open master data symptom description.csv as CSV file for row in csv.reader CSV file description list row 0 equal to row 1 reads the description disease description into a dictionary. Similar logic for def get severity dictionary def get precaution dictionary. Load severity integer and precaution list of 4 strings. Get severity dictionary get description, and get precaution dictionary execute all three to fill dictionaries. Symptoms and symptom extraction. Symptoms and symptoms. Stomachache equal to stomach pain. Maps common phrases to standard symptom names. Def extract symptoms user input all symptoms extracted text equal to user input dot lower replace converts user text to lowercase first matches known symptoms then checks if any standard symptoms name appears. Uses get close matches for fuzzy matching. Returns unique detected symptoms. Disease prediction. Def Predict disease symptom list. Input vector equal to np dot zeros length symptoms dictionary. Creates a binary vector marking which symptoms are present. Model dot predict probability of each disease. Picks highest probability and decodes label. Return disease name, confidence percentage, and the whole probability array. Then for motivational quotes equal to health is well randomly shows in final output. Flask routes @app.root def index session.clear session step equal to welcome return render template index.html root pages reset session sets first conversation step @app.root chat method equal to post def chat user message equal to request.json message step equal to session.get step welcome main chat endpoint reads the user message and checks conversation step conversation state machine each elfif handles a step name age gender symptoms etc store responses in session so it remembers across requests add symptom step extract symptom from text, predict primary disease, and stores it. Later steps collect extra information about days, severity, lifestyle, etc. For guided question, disease symptoms equal to list, training, prognosis equal to disease. Retrieves typical symptoms of predicted disease to ask follow-up questions. First is guided question function. Def ask next symptoms. Ask up to 8 yes and no follow-up symptom questions. Def final prediction. Final disease prediction using all confirmed symptoms. Builds a detailed text with disease name and confidence, description and precaution, random code, and username.